Hey everyone, hope you are enjoying Data Science Connect as much as we are. I am Thom, the Director of Platform Marketing from Mobilewalla, and I have a couple of guests here with me, and some more should be joining shortly. We have a little panel today where we are discussing driving successful AI projects at scale, what's needed in your industry. And we're going to go ahead. I'm going to start off by letting both of you introduce yourselves. Chantel, if you'll go first and introduce yourself, tell us who you are, where you work, what you do day to day, and any exciting analytics or AI projects that you're working on that you can talk about.
Sure, for sure. Hey, everybody. My name is Chantel Perry. I'm a senior data scientist at USAA Bank. I work in financial crimes. Excuse me. I work in the financial crimes division. We build machine learning solutions to hopefully detect fraud before it happens and stop fraud. And excuse me, I'm sorry, I need some water. And stop fraud in real time. I'm going to go ahead and pass the mic.
Hi everyone. My name is Shanshan. I am the director of data science at Hinge, which is an online dating app. I lead a team of data scientists who leverage machine learning and advanced analytics across the product and business. Some major use cases include the Hinge recommender as well as trust and safety.
Awesome. I imagine working on the AI that matches people for dating is a pretty intense day-to-day job, isn't it?
It's interesting.
So I've got a few questions for you, and we'll ask everybody else once they join as well, just to get a better idea and understanding, so you can share some of your experience about the AI that you're doing in Hinge and what you've done outside in the past. We have another guest joining us now. Thank you so much for joining us.
Of course, it's an absolute pleasure.
If you could, what we've done is Shanshan and Chantel have both introduced themselves and just said where they are and what kind of AI projects and analytics projects they work on day to day. If you would mind introducing yourself, and then we'll jump in with a few questions.
Okay, well, my name is Kratik Malholtra. I'm the director of sports science and analytics for the Texas A&M football team. I studied engineering for my undergrad, like most Indians, but for my master's I studied I studied basically sport management, and I focused on sports analytics. And yeah, a lot of my projects depend on analyzing opposition to scouting opponent players, to scouting the players that we're recruiting, to also dealing with an athlete's health. So the heart rate, the accelerations, decelerations, the speeds, the distance that they are covering, making sure that we are in tip top shape going into every single practice, tip-top shape going into every single game. Since the time we started using sports science, basically what I do, like we've cut down on 89% soft tissue injuries, and it's been a huge success. And working with a head coach like Jimbo Fisher, that is a huge bonus.
That's not an application of AI that I really think of in sports. When I think of sports,
Yeah.
I think more of the stats and the gaming side of it. So that's really interesting to hear about that.
Well, the cool thing is, sorry, go on.
Oh, go right ahead.
The cool thing is you can use neural networks, and you can use optical flows and computer vision to design systems and to design to design models that can help predict when what play is an opponent gonna run. How is an athlete getting closer and closer to getting injured, getting closer to a soft tissue injury. And that happens when to push him, when to pull him back, so that he's in the best possible shape going forward.
Now, I'm a Texan living in Oklahoma, so I saw how well your analytics worked a couple weeks ago, right?
That was Jimbo Fisher. That was not me, but
oh, it brought a smile to my face, that's for sure. So I've got a general question for y'all. What are some of the biggest challenges that you faced when scaling up enterprise analytics, AI, and machine learning projects? We all know, everybody I'm sure on this call has experience with smaller projects, but what things did you plan for, and maybe what things did you not plan for when you looked at scaling?
I can start.
Okay, awesome.
I think when I think about scaling AI or analytics, there are maybe 2 or 3 challenges. The first is that the kind of topics you learn in like a school on data science or AI, to translate it to actually work in a real business or product has a lot of steps that you didn't learn in school. So, to build an AI solution, you need to have data that's available. That data needs to be transformed. And then that, you need to train a model, you need to generate predictions, and you need to serve the output of that predictions. What you typically learn in school is the middle part, training a model and generating predictions. But everything else also needs to be done. And often it's not clear in a company who's doing that. Is it a data scientist? Is it engineers? If it's engineers, is it machine learning engineers, data engineers, backend engineers? So what is everything that needs to be done and who's doing it is actually something that often needs to be very explicit, and that often is missing in discussions when you kick off a project. And I think another challenge related to the engineering aspect is, scaling itself, right? Like what often works in an offline like software, it would run in a few minutes. When you run it on millions of real life like data sets that are real life size, take days potentially to run, and that could completely mess with how you wanted this the system to work. And then the third thing I'll mention is, I think what's really interesting about a lot of AI systems is that introducing these systems actually change the underlying parameters that these systems are built on. So a really great example is when you build a recommender system. You build it on existing data. And what you're really doing when you're training your model on existing data is you're resorting existing recommendations. But when you're deploying the system live, you're actually surfacing recommendations that would never have been surfaced without the system. So the data that you use to build the system is different from the data you see when the system is live. And because of that, there often is a huge difference between how a prototype is working and how an actual system is working. So I think those are some of the themes that I have seen when I'm trying to scale AI or analytics.
Chantel, did you have anything additional that you've noticed within your org?
Sure. And sorry about earlier, a little dry over here, but I'd love to piggyback off of what Shanshan said earlier. We have a process in which our data science team actually builds our own data pipelines. We build our machine learning models, and we actually pass these off to an IT team who implements these things in production. So they're implementing it off an operational data source. But we actually train our models on an analytical data source, which is very different sometimes from the operational data source. So by the time you get from the process of like actually training and testing to production, you may have a totally different outcome on your model. And then on top of that, we have to implement things in real time without actually interacting with the member and what they're doing. So let's say you're logging into your account, looking at your mobile app, and we're trying to see if you're a fraudster or not. So we have to, during that small, short window, have to go in there and say, hey, is this who they say they are? Are they a fraudster? And have to do it quickly. So our technology stacks have to be on point for us to be able to quickly aggregate all of this information and all of this data in a real-time manner as to not hinder the member experience at the same time. So I think that those two are the biggest challenges I see when I'm working on machine learning projects.
So you not only have to do it at scale, but you have to do it in a very tight time window.
Yeah, there's billions of transactions coming in. So, right.
But it sounds like operationally, y'all have a solid infrastructure for how you pass off the work. So you're avoiding some of those problems that Shanshan had mentioned with who does what, right?
Correct.
Gotcha. And Kratik, how about you?
So the biggest challenge for us, and when you talk about scaling and getting machine learning in and artificial intelligence in, um, so most coaches, forget college football, in the world are still old school. You find a few handful guys who are willing to use data to make decisions, and Coach Fisher is one of them. Now, the biggest challenge that we have that I've had, and I was one of the first sports scientists working in football. One of the biggest challenges that I've had is communication. You can't literally tell a coach everything, right? So you can have your machine learning techniques and you can have your AI techniques, but but you need to know what to say, when to say it. Also, when you guys mentioned, it's about solving a problem, right? Output is very, very important. What is it that the coach really wants? So when we started using sports science and GPS, um, it gave information about an athlete's movement, but we had no information about an athlete's football stats in practice. So, completions, incompletions, trying to draw chemistries between a receiver and a quarterback, and then combining that with his speeds and accelerations. If a guy's running 21 miles an hour, is he running the right route? And how can we maximize that to get the most out of the athlete? If you're talking about an athlete's anxiety, now again, anxiety metric is something that we had developed, and one of the cool things that we found out was we had one of our quarterbacks whose heart rates would spike right before the ball was snapped. When I took that back to the head coach, he was like, that's happening because the kid doesn't know the play. So his focus for months was to make sure that, like he learned the playbook and came back was a different kid. But the thing is, the machine learning techniques, all of that is great. But for me, I think the biggest challenge that we have is I need to I need to use machine learning techniques and I need to use neural networks and AI. But the data that needs to be communicated not only to the head coach but to all the coaches needs to be very, very simple. Right? Like what they say, if you can't explain something to a baby, that means you just don't know it good enough. So when you do come up with the result, you first understand it to your best possible ability. You explain it to yourself, and then you decipher on how you're going to tell the coach and what's the easiest way to tell him that he gets it, and then he can make changes on the basis of which you're telling him. Because once you're lost in translation, it can go downhill real quick.
That's the key right there, that translating what you know, your knowledge and what your models are showing you to people who don't understand machine learning and AI and or even really understand analytics. I mean, you're
Yeah.
working on something that's so cutting edge and such a new field that it hasn't translated over to people really outside of your teams, right?
Yeah. Well, and the thing is, so like we use Pro Football Focus. They're a company
Hmm.
based out of Cincinnati, and they provide great data. But like where smartness comes in from my perspective is to see what you're going to use and what you're not going to use. They probably give hundreds of metrics, but we'll probably use 15 and combine it with everything that we collect and use it to the best possible ability. Like we talk about cleaning data, right? What
Hmm.
metrics? This is very simple, but like what metrics have to be left numerical, and what metrics have to be converted into categorical? Like that's such a key, um,
Hmm.
and that can tell you so much about a team's play. Whether you're going to consider distance as 0 to 3, are you going to consider down and distance as 0 to 4? Like that makes such a huge difference, you know. Um, and obviously, you're using classification modeling and you're using even data visualization to see what works for you.
Now, kind of building on this, can y'all share some example of a time where scaling up an analytics or AI project has worked really well within your organization? I know you can't go into too many specifics, but a project where you were able to take that and do it at scale and it worked the way it was supposed to. And Chantel, do you want to kick this one off? I see you nodding your head.
If I could find the mute button, for sure. One of the big projects we worked on, I think I mentioned a little bit before, is working on authentication during login, making sure that that authentication process is really secure and stopping fraud during the login process. I would say that what made that project really successful was that there was buy-in across the board. That's first and foremost. There was a lot of leadership buy-in, all stakeholders were in. And I think that part of that was due to everybody knew the ROI that was at stake. We were basically hemorrhaging money due to people being able to bypass that login process very well. And there was also the aspect of members not, having a harder time getting into the door or logging in and not having some kind of something in place that was more like an invisible authentication type of system. Any kind of security they had before them was hindering the members' experience, and then members were leaving. So there was a huge need. So that leadership buy-in was very critical, and that everybody was on the same page. And because of that, that allowed us to bring in the technology we needed to get around things like not being able to have features in real time and not being able to implement everything in real time. We were able to bring in technologies like Cassandra, Spark. We were able to have like Hadoop and things like that just due to having leadership buy-in. We were also able to collaborate with teams all across the organization and bring in talent that we needed who were able to say, hey, you know what, these people are great at machine learning. These people are great with the data science process. These people understand the infrastructure over here. So we were able to also get a lot of people to collaborate, and that was helpful as well. And one of the big things about that project that I felt really, really helped was that we were able to phase out, do like a phase rollout release. So we were able to test out our product on different customers, different groups and segments at a time. So that also helped us while we were scaling up and building out our infrastructure. So I think those were the three big things. But of course, buy-in was the hugest component for us.
How about you, Shanshan? Do you have a good example of where scaling out worked well for you?
I think every project, there's I think, similar theme in kind of what works well and what doesn't work well. And it really builds on what Chantel and Kratik have mentioned, which is that communication, alignment, and buy-in. Every good project, what they have in common is that these three things went well. You need like alignment from top down. What is the problem you're solving? And is AI the way to solve it? I mean, AI is not actually the way to solve every problem. There are many problems that does not need AI, or just need something extremely simple. And then, with that alignment, what is an MVP? And stay on task. What is the resource? What is the timeline? I think that's what every successful project has in common, is that people talk about all of that upfront and they stick to a plan.
Kratik, do you have anything from your experience to add?
I think those are great points. I'd like to kind of add in the buy-in. I think buy-in for me, somebody in my role, is huge, because if a coach doesn't buy into it, you can bring the sun to earth, but there's like nothing's gonna change. You can cause miracles, like nothing's gonna change. And I'm very, very blessed in my position because of the head coach that I work for, and how much he buys into it. Secondly, like you're talking about scaling up. Scaling up for us has been huge, because when I first started, this was 2013 at Florida State, 2012 at IMG, then Florida State, we were only using GPS system, right? And then we started using heart rates, and then we started using biomechanic sensors, and then we started using foot sensors for our kickers, and wrist sensors for our quarterbacks. And then we started, integrating video into the thing, and then started video coding, and now recruiting and all of that. But there are so many things along the way that you find out that you don't really need, or like stuff is not working. Scaling up is very, very important, because you obviously need to grow yourself, but you also need to grow the field. But at the same time, there's a lot of stuff that you do that, you might do for 2 years, and you might just look back and might be like, that's useless. And why was I even wasting my time on it? Like one of the things this is 2014, and I thought we could predict injuries. So I took all of the soft tissue injuries that we had had in like the past 5 years, and on not 20, probably 2015, yeah. Took the soft tissue injuries that we had in the past 3 years, took all the data, the speed metrics and everything, and I tried to predict. I used regressions and trying to predict, when is a guy gonna pull hamstring. And in fact, we even ended up sending data abroad to make sure if we can get something. Um, Obviously, I had made it anonymous, but send it abroad to make sure we get anything. After a year of doing my research, realized that was the greatest waste of time. You can never predict when is a guy going to pull his hamstring. The closest that you can get is you can be like, all right, this guy's imbalance is going up, so he's putting more pressure on his right foot as compared to his left. So he may have something there, and he's probably in the red zone. That's the best you can get. This is years ago, and people laugh at this when I tell. I told, we were in the staff meeting, and I told Coach Fisher, I was like, you need to pull this guy back. This guy's probably going to get hurt. And he's like, well, I don't have tight ends, and he obviously played the guy, and he had a lot of the reps, and the guy was fine the next day, perfectly fine. and he looks at me, and he looks at me next day in staff meeting. He's like, he didn't get hurt, did he? I didn't know what to say. I was like, but at the same time, like, there's, like Chantel was saying, like there's so much stuff that doesn't even need AI, and we try to put in AI and machine learning, and we try to make sense of everything and predict things that technically can't be predicted or don't need that kind of prediction. And you got to be just careful with that. And you were talking about buy-in, like once you go wrong so many times, you tend to lose that buy-in. So in our own sense, and for our own job securities, you can't be taking those kind of risks, and it's but it's awesome. Scaling is very, very important for us, for the field.
So what I'm hearing is nobody's going to get that silver bullet that this tooling or this particular product is going to help you scale. You've got a lot of not only the technology, but you have to work within your org, and there's just the normal politics to get things done, right? That's good advice. I really liked your story, though, about how you spent a year trying to predict injuries and found out it didn't work. Do either of you two have any experience trying to scale up a project and ran into problems and have lessons that you learned in your experience, Chantel or Shanshan?
I think when I think about AI projects that we have worked on, such as for instance recommenders, I think one thing that I had to learn that maybe wasn't obvious to me earlier in my career is that every time you build a system, it doesn't just end. It doesn't mean you're done. There is a lot of monitoring and maintenance that needs to go into continuous work on the system. You need to see how it's reacting, how it's working. When there may be an underlying data change, when maybe the product or the business change that interferes fundamentally with the assumptions of the system, people need to make those changes and continuously assess. I think that is probably part of the calculus I was missing earlier on in my career. And that probably for me is the biggest lesson, is that when you build something, you're not just done. You have to continuously invest in it.
And I can definitely attest to that. One of the big things about our technology stack and all of our different models is that something's always upgrading, migrating, needing enhance. People are changing data sources. One model works one day, all of a sudden the data's gone. Now you have to figure out where you're going to get it from. So I think that our biggest challenges are just that, trying to ensure that these things are maintained. And then on top of that, trying to even improve on those processes. One of the big things that we've worked on in the past is automating the model retrain process, because once you have a model and there's new data, you're always having to retrain that model. Like, how can we automate that process so we're not putting all these man hours on not only just retraining it, but now IT has to go and put this new, pickle or whatever modeling object you're using into production, right? So that's another big challenge that we deal with, is trying to see how we can reduce time using automation. And yeah.
I really like what you said, Shanshan, about what was missing from your experience, what you couldn't pull on early on in your career. Do y'all have any other advice you would give to somebody who's starting a new project or somebody new to the field? Some things that you wish you were told early on when you were starting your projects? I like the head nods. This is encouraging.
Well, I would say just be patient. Everything's just gonna come. Just be patient, relax, and you'll kill it. Because especially like, in my position, like, you want to do everything on day one, and when stuff's not working out, like, you tend to get frustrated. Don't get frustrated. Things will work out. You don't have to figure everything out in one day.
Yeah, just I imagine, especially in a field like this where everything is ever changing and ever evolving, it's nothing's ever going to be perfect, right? Everything's going to take work. Yeah. Shanshan, did you have anything to add?
Yeah, I think the one thing I'll add is to think carefully about if you want to build some capability, whether to build that in-house or to buy it. Both have pros and cons. If you buy a third-party vendor, you don't fully control what goes on with it, and they could terminate their service at any time. But if you choose to build something in-house, that typically means you have to hire people. It's very resource intensive. And you could find yourself, a year into a 2-year project only for some industry leading, vendor to come out with a new version of some software that does exactly what you're trying to build. So the decision of whether to buy or to build is something that for every project, every company needs to think carefully about.
One of the big things in that I've seen is there's always that upfront cost to buy a service that people typically balk at, right? You see that big number and it hurts. But then when you start actually building the project or trying to do something yourself and start hiring more people, there's more infrastructure and personnel costs than you anticipate when you start that project in-house, right? All the time. That's really good advice. Anything you've learned, Chantel, that you can share, or anything you wish somebody had told you earlier on?
Definitely. A couple things. I think the biggest one for me is when people come to me and they talk about, data science, wanting to get into the AI field. I think a lot of people lose sight of the fact that we're dealing with outcomes that impact people. Sometimes I would always say, like, keep the fact that you're impacting people at the forefront, and that'll definitely help with some big decisions. Of course, at the end of the day, there's business value, which, you go to a company, they want to know what kind of impact you've made for the business, but it also impacts the customers, and you definitely want to keep that at the forefront. At the end of the day, there's going to be some people who we protect and we're keeping people out of their accounts, and there's going to be somebody who swipes their cards and the fraudster got in the door, and you have to try to make the best decisions to protect as many people as you can. So I think that that's usually how I like to look at it anyways, keeping people at the forefront. And I think the only other thing I would say is, I think we hit on it a little bit earlier. Every solution doesn't need AI, or it can be something small delivered up until the point till you get to AI. So, if you can bring data in and you can build BI reports or do some basic predictive analytics first, then utilize that. There's, value in that. Don't think everything has to be grand from the start. Utilize those little pieces to deliver little bits and pieces of value until you get to that point in your data analytics journey, wherever you work at too.
Well, perfect.
Something to Chantel's point real quick.
Of course, go right ahead.
Chantel had mentioned about getting a third company, and I think for us, the biggest challenge for us, and it's been, is you have it's confidentiality, because a lot of stuff that we do, they're basically trade secrets. And I'm sure that's with everybody listening and you guys, I guess that's the same idea. What we are doing, we don't want other teams to know what we are doing and how we are doing it. So when you get another company in, and this has happened in the past, you get another company in, and them, even if they say they're not going to tell somebody what you're doing in order to sell their system, they, in one way or the other, they tend to do that. So confidentiality is a big thing for us. Also, like, you're dealing with player injuries. Now that's data that cannot go out. That's illegal for that data to go out. So now if you make it anonymous and you're dealing with athlete data of, like 500, 600 players for the past few years, that's just very, very hard to keep up to. So, I mean, the you need to find that perfect balance, what you can do, and whom you can trust from the outside, and who's going to deliver the best service. But also, you need to be very, very careful about what you can do in-house, because that can so easily get overwhelming.
It's a tough balance to find, that's for sure. Well, thank all of you for joining us today for this panel. I think it was really enlightening. It's always interesting to hear from people who are the practitioners doing this every day, leading the teams that are doing that are building these models and doing AI. So we really enjoyed hearing your insight. I think it helped a lot. And yeah, so thank you. And I think we're heading into a break now, and we'll be back in a little bit for the next talk.
Thank you.
Thank you.
Thank you.
Thank y'all.
Thank you.
Thank you.